So what we're going to be doing now is we're going to be working on this little 4-tube Nixie Therm. So off camera, I've already done three out of the four Nixie tube sockets. And these Nixie tube sockets are kind of cool because they're a pass-through. So any kind of wire will just pass right through them. So there's no restrictions on dead end normal type sockets where you gotta have it at a certain depth and have all the pins all nice and uniform and stuff like that. What's nice about these is that you can stick the Nixie tube as far in as you want, or leave it up as far as you want, and then just go underneath and clip the leads, and then you're done. There's no having to worry about that one leg that's a little longer than the rest, and it makes the thing all cattywampus and stuff like that. So we're going to work on the final tube socket here. So I'll bore all you to death by putting all these little tubes sockets in, and after that we'll work on the LEDs. So they give you plenty of extras because they already know that you're gonna flick some. And this one doesn't have all the tubes, all the wires that go all the way around. It's one of them tubes that you gotta omit or fold away a leg because it's not used. So these little guys are not a snap type fit. They don't just snap in. They just sort of sit on top of the board. So you're going to have to secure them so that when you flip it over, they don't go flying. So lots and lots of extra parts. I even noticed they actually give you an extra, I think it's one of the high voltage chips. And even a spare step-up transformer. So that takes care of the tube sockets. Now we got to secure all this before we flip it over. So I'm just going to take a little bit of polyamide here. Or you can use blue tack or tape or whatever. But this is what's here, so that's what I'm going to be using. So we'll get it all the way around the board, all the way around the sockets on the outside, push in the middle, so there's no chance of it moving, and then just flip it over and tack them down. So these are very small, so you don't need a lot of solder. So for me, I got this really, really tiny, very thin gauged solder wire. So that takes care of them. And that's the final socket pins for the board. So now we can take the tape off because we're done with that. So now the next step is we're going to put the little LEDs in. So in the kit they gave me red ones, but I'm not a fan of the red lights on the Nixie tubes, so I'm going to put warm white in. And for this installation on this board, we're going to be putting all the long legs on the left side because the flats on these are on the right side. And then later on, I'll have to deal with the resistors that go for them. And they're a specific type for red. So later on, I'll figure out the voltage and then use a appropriate resistor for warm white or white. I think these are white. So the holes for these are huge. Just make sure that the LEDs are flat to the board. Okay. I'll just snip the leads. takes care of that. So now when we flip it over, we've got the finished look of the sockets and the LEDs. So now the next one is, I guess we'll put the high voltage transformer in. So that goes over here. And these guys can only go in one way. So one side of the board has 4 through holes, and the other side of the component has just 2. So he kind of hangs out like that. Of course, it's perfect time to put it on the right side of the board. Okay, so it takes care of that. So that's the high voltage transformer. So since we're on this side of the board, we got a spot here for a capacitor, and it's a electrolytic. So we got 2 capacitors in this thing, and the not micro, but USB mini plug in this bag. So on the board here, we got a plus and a minus. So the white mark on the board is the minus side. And this is one of them guys where you kind of line it up. You got to fold it over. You might have to push it down a little bit because he's going to sit flat, kind of like that. So speaking of capacitors, there's another one that goes right here. And same thing with these low profile guys. There's a mark for the negative side. Takes care of that. So that's all in. And then the next thing is our final component in the bag was the connector. So we'll take this and move him over as he hangs out in here. So I can have something to hold that. So I got a little piece of tape out. So that's the mechanical bond to the board. So really all we're using on this thing is just the power and ground. But we can use all these little micro pins for also additional support. And then one of them is going to connect power and ground. So that's one bag down of parts. Takes care of that. So now I got to refer to the instructions and continue on with the rest of the build. So it'll be a little flip of the page. So now we'll work on the next little part of this board here. We'll go ahead and put on some of these chip sockets. And then there's one here that doesn't have a chip socket. It goes directly on the board because it's related to the high voltage to drive all the tubes, so they don't put it in a nice little chip holder here. They just say solder it to the board. So we got a large chip holder, and it's got a notch on one side to help you line up the notch of the chip. So we'll put him in first. And then just for now, I'll put a little piece of tape on here. Just to temporarily hold it. So we'll do one on each corner. And that'll hold it. temporarily. And then we got our medium-sized little chip holder here that will line up our little notch. Okay. So that's our chipset socket holders. So now a nice job of soldering the rest of the pins in. So that takes care of the chip sockets. So they're all nice in there. So now our next little chip here that we have to put in is our little high voltage guy. And he's got a little dot and a little notch. So the little notch and the little dot face our little transformer here. So we got two of them in case you blow one up. So sometimes with these little guys, you kind of fold the legs in just a little bit to get it to fit in there. And it's a little fumbly. But you want to make sure all the pins go in. because they're only fine wire. And it'll be easy to bend one and you wouldn't even see it. So that's that little socket chip. So our next interesting things here is our little octo couplers that are on this. And these guys got little dots on them that face the notch. So we'll put them in. Sometimes you can hope that the friction just holds it in there a little bit until you can get one of the legs pinned down. Then you can reach from the backside and press it flat. So our legs are, one leg is firmly attached. We got all our octo couplers nice and flush against the board. So now we can just finish the job and do the remaining three of the four. 3 legs over the 4 couplers. So that takes care of all of them little guys. And just look to see if they're all flat. They all are, so that's good. So now later on we'll put the chips in when we're all done messing around. So our next biggest component we can put in is our actual temperature sensor. So this is a DS 181320, but the kit also has the optional 3.5 millimeter jack and for an external probe. So if you want to have a little external probe, you can have that. That is available in the kit, where it's all in the parts here. So you would have to solder in the jack and then acquire your own temperature probe. But we'll stick with what's in the kit for now and see how well it does. Because I know Nixie Clock Yana there, the temperature probe is underneath it. So the heat from the chipsets and the board kind of affect the temperature. So this is like a regular transistor. So you got a half moon on one side and a flat on one side. So you just match that up to the board. This is going to be one of them deals where you just want to get the bare minimum soldered to the board, and then the rest of it you're going to fold over and leave it hanging out to the side. So something like that. And you want just a little bit sticking through, because you're going to fold over the transistor so it has less influence from heat coming off the board. And here's the provisions for the 3.5 millimeter socket. Then just take this and just fold it over. And that's all you're going to do for it. So now for the fun part, to put in all the various resistors in and capacitors. So the capacitors are the next easiest thing to put in. Other than the one I've already put in. So we got three little capacitors to stick in there. So we got a can't tell what's on the board. I think it's 1 picofarad. So we got 2 of them. So one goes down here by the chip. Then we got one up here by the high voltage chip. And these little guys are not polarity sensitive. So one goes here, and this little tiny yellow one goes up here. Set them little guys. And you can straighten them up, make them look pretty. So now on here is a couple of jumpers on the board that we have to solder together. These are put in place to isolate the high voltage, so in case you want to play with the troubleshooting, that you can disconnect the high voltage from the rest of the board so you can troubleshoot. So we have to do the famous solder blob and join the two pads together. And there's two provisions on the board for that. So that takes care of that. Make sure you're connected. So now we got the 1, 2, 3, 4 resistors down here that we're not going to worry about right now for the color of the LEDs. So now we got to fill in R1, resistor 1, resistor 2, resistor 14, and resistor 15, and resistor 12, and resistor 9. And then we got resistor 7 down here. And then we got a diode here to put in, a diode over here to put in, and that is that for the components. So we'll put the diodes in. So a Xenier goes over here, and the regular diode goes on the other side of the transformer. So our little Xenier here, it's got a little black stripe on one side of the diode to indicate which way it goes. So the black stripe is going toward the sockets. So all we got to do is carefully fold the legs over. And this is glass, so you don't want to try to get the bend too close to the glass because you might fracture it. And if you don't go in all the way, don't force them, because you might fracture it. But this is pretty stout wire, so we're gonna try to get the bend as close as possible. Then our little diode here is right here. So stick him in. So usually when you get components like this, you got this sticky tape on there. It's best to just to cut them off, so you don't have to worry about the adhesive contaminating the through hole. So just like all diodes, they got a little stripe, and you match the direction of the stripe on the board. So now, in our next little segment, we'll put all these resistors in, and we'll put some tubes in, and then the chipsets and stuff like that, and see if it smokes. So that will be in the next segment. So now we're going to put in our remaining components, which are resistors, and we're going to be referring to the through the circuit diagram here so we can get the proper resistors in the proper positions. So we'll start at the bottom of the list, which is going to be our 120K, and it's going to be a half-watt resistor. So this is our chunky 120K half-watt resistor, and he's going to go in R8. So R8 is right next to our Xenier diode. So we'll put that in there. So this is one of them situations where the spacing is tiny. It's a lot smaller than the resistor. So sometimes you can you'll have to finagle these leads, where you kind of fold it under each itself, and then you got to bend it back out straight. And that's if you want to have the resistor sit flat on a board. And some people don't care what the resistor looks like, which is fine. That's up to you. Just want to make sure that you don't have the leads touch. And sometimes you just can't get it to line up nice, so you'll just have to say, screw it, and just have it do whatever. So that takes care of that one. So now we got R1 and R2 on the same side of the board. So R1, it's going to be a 10K. got one of these little guys. And then speaking of 10Ks, we got our another 10K here, because they're both 10Ks for R1 and R7. So that is R7 down here. So we'll get another one of them. Okay. So that takes care of them two resistors. And then our next R2, that's R2. R2 is going to be a 1K. So I believe that's this one. It looks like a 2C, but I guess it's a K. Then we got R14 and R15. 14 and 15, so we look on our little chart here. And it's not listed. So that must be an extra for something. Probably for this extra bits here. So now we go on to R12. So on our little chart here, we got an R12. It's going to be a 10K, half a watt. So we got two different 10Ks. So these 10Ks are a lot bigger than that 10K. Take care of that. And now we got a R9, I think that is. So do we got an R9? Yes, we do. And it's a 1 mega ohm. So we got a 1M. So we got an extra resistor here. I have no idea what that says. A 7K, I guess? Oh, a 7.5. Okay. I guess that's a 5. 7K5. Okay. That's that. So that goes in R10. So that's this one going up alongside of the capacitor. Okay. So I'll just check the list here. So we're not worrying about the LEDs. So we got R2, that's done. We got R9, that's done. R10 is done. R1 and R7 are done. R12 is done and R8 is done. So we got all the resistors in. And of course there's an extra 10K for something that's not on the chart here, so. Okay, so we're soldered in them in, and then it'll be time to install the tubes. So take care of all our little bits and bops. So now the next thing is we'll put some chips in. So the big chip, it's got a notch on one side, so the chip goes in here. You want to be careful that you get everything lined up. sometimes you have to press these in a little bit. Takes care of that chip. And then our medium-sized chip. Just want to make sure you got all the pins in the holes before you set it in. So you don't fold anything underneath itself that you would never see. So that takes care of that. So I think all the major building is done. So now the next thing is to put in all the tubes. So for reference here, this tube is going to be our plus and minus tube. That's all it's going to display. These are our numerals, so this is our 1 through 9 on each tube, and this one's going to be a sole tube that just says F. And so I won't bore you of installing tubes because they go on this side. So it looks all pretty with the LEDs shining underneath of them. And then I'll have to figure out what voltage is going to them, and then put a appropriate resistor for whatever voltage. I would imagine they're 5 volts or something like that going into the whole array here. Or it might be lower, I don't know until I test it. So that'll be the next step for me, is to put the tubes in, and then we'll come back and see if it smokes or if it does anything. So stay tuned in the next segment. So got all the tubes in, as you can see, and the beauty with this particular kit, like I mentioned earlier in the video, how the tube sockets are they're hollow, so everything passes through. So it makes it so much easier to put these tubes in, because I can spiral the tube legs to make it easier to install into the board. So you start with the anode and you just make each leg going around just a wee bit smaller, and it makes it so much easier to install tubes. And now all I would have to do now is just go on the underside here and just clip all these off, and it's done. The project is done. So now it's time for the big test. So it was provided with a very nice USB mini. This is actually a very nice cord. It's got nice grips on here. Very well made cord, that's for sure. So we got that. So on the back of the board here, we got our connector. USB mini. So now we can turn some lights off and see what it does. So I need to find my extension. Turn this one off too. Oop. You see anything? Probably not. Doesn't matter. Okay. So we got plus 23 hertz. Well, that sucks. So the problem is I was sent the wrong chip. So the main controller chip, probably this one here, or this one, it's not set up for Fahrenheit. So since I have the correct tube for what this would be normally saying F, the controller chip is powering up the wrong pin of the Nixie tube and saying that it's driving the wrong segment of the Nixie tube. So this was the other 19B tube that I tested here. So this is the this is the 19A. So if this was the 19A, this would be displaying Celsius. But since I have the other tube here that's supposed to display the Fahrenheit, and this is the 19, it's got the special character on the end. So if this one is, because I got it marked as F, and this one is the plus and minus. So that's right. The ion 14s are right. It's saying 25C, which is almost dead on of the temperature in here. But so it's about 72, 4, 6, about 77 in here. But it's getting heat off the computer and stuff like that in here. So it's really only about 73.6. So close enough. So I got to contact the seller where I bought this from and get the right chip, and then it should be saying about 74 degrees F. So I'll have to wait a while to get a new chip. So that's pretty much it for this video. Another successful build. When I change the chip, it will automatically work correctly. So everything I did was correct. The soldering and the chip placement and all the resistors and all the capacitors and all the octocouplers, and then wiring in all the chipsets and the sockets. The little thermocouple here. Thermal thing there, like I said, to give you any option of having that remote. So I'll hold this a little bit and we'll watch the temperature go up. So this is a nicer kit, unlike my other kit, where it displays the temperature by the ones, where the other one was by the twos, so 2/10. So this one registers by the tenths, which is a lot nicer than 2/10 to watch it. So, like I said, we'll get the in the future we'll get the correct chip. So it says 74 degrees Fahrenheit, but like I said, another successful repair. I mean, yeah, it's a long video, but you just have to suck it up. And it doesn't matter anyway, because you'll skip ahead to see if it works anyway. So that's it for this video. Thanks for watching, and we'll see you on the next video. Bye-bye.